either or.
But I'm never gonna be able to not figure it out if I have a.
Can you figure them out with the notes in front of you? Like with the identities in front of you?
Like the paper you gave us yesterday, like if I use my notes, I could.
Did the paper just not have enough of them on it? What was different about the paper than about your notes? It didn't have the negatives. Okay. Okay. The pi over 2 minus theta. It didn't have those. But that was the only one it didn't have, right? The pi over 2. That's not a very common one. Okay.
Are we gonna have some of these?
Well, I'm thinking I'll give you a reference sheet of identities on the test, and you'll have to work through. I don't know. But I need to figure out. I need to work the sheet out. Okay, give me a question from your homework. 2, 27. Thurbot did do them. You listened to Davis? There's mistake number 1. All right, I'll do 2, and then I'll come back to 27. Number 2, find secant theta and cosecant theta if tangent theta, it is on mirror board now, is 3 and cosine theta is positive. All right, and it says in the directions, which I helped somebody with it whenever y'all did it, and I didn't read the directions thoroughly. You have to use Pythagorean identities. Even though you could set up a reference triangle, you have to use those Pythagorean identities. So those are the 3. That's the sine squared plus cosine squared equals 1. The 1 plus tan squared equals secant squared. And then what's the third one? Cosecant squared plus 1. Cotangent squared plus 1 is cosecant squared. So, any ideas which one I should use? Tangent squared plus 1 equals secant squared. Charlesy, what led you to believe you might need to use that one? That's exactly right. You have tan, you need secant. So use it. So tangent squared would be what? 3 squared, which is 9. So I've got 10 is secant squared, but it just asked me for secant, so what should I do? Are you doing a snowman? I just said that example. I mean, unless you're talking about a snowman or a snowman. Like if you're talking about snow, I don't know. I don't know. If you're talking about like Frosty the Snowman, snowman is one word. Yeah, clearly. All right, how can I use this then to find cosecant? Crickets. Okay, so the flip of this would give me what? What did y'all do? Oh, I see what you did. I was going another way. I was going to find cosine and do cosine squared plus sine squared equals. Okay, that's okay. So you did, for this one, you did cotangent squared plus 1 equals cosecant squared. Is that what y'all did? Cotangent, well, what is cotangent? 1 over 3, right? If tangent is 3, then cotangent is 1 over 3. See how there's multiple ways you can do this? I think this is why y'all get confused too, because there's not just one way to do it. It's kind of like those exponent properties and the log properties and things like that. There's not a right or a wrong way. It's just following rules as you go. So 1/3 squared plus 1 gives me cosecant squared. What is 1/3 squared? 1/9. What's in green was given to me here, so yeah. If tangent's 3, then cotangent would be 1/3. 1/9 plus 1 would be 10/9. So what's cosecant? Did you come back to the same thing? Okay, so the reason we use these is because it said we had to use the same. And you have to use one of those 3 percent. What else on your homework? Oh, yeah, what else?
If I would have done it like the sine square plus cosine square, would it have just been like 1/10?
Yes. If you'd have done, are you talking about here? If you kept going that way? So if you'd have done this, you would have said that cosine theta. So then I would have said that sine squared plus that squared plus cosine squared equals 1. So sine squared theta 1 over, oops, that's a plus. Subtract 1/10, so sine squared theta would be 10/10 minus what would be 9/10. Is that right? Square root. So sine would be 3 over the square root of 10, and then if you flip it for cosecant, you come back to that. Oh, that's why, yeah. Y'all okay? 20? 20. Yes. So number 20 asked us to simplify to either 1 or -1. Cotangent of -x times the tangent of -x. Well, what's the cotangent of -x? Negative cotangent x. And what's the tangent of -x? Negative tangent x. Well, a negative times a negative is what? A positive. So now I've got cotangent x times tangent x. Well, what is really cotangent x? 1 over tan. So 1 over tangent x times tangent x. The tans cancel, it's just. What else? 27. Oh, that's a good one. Sine x times the tangent of x plus cotangent of x. If you ever get to a point where you're not really sure what to do, try changing your tangents and cotangents to just sine and cosine, because it could very well help you at that point. Here, I'm probably going to go ahead and do that. I'm going to change this tangent to sine over cosine, and I'm going to change this cotangent to cosine over sine. Does that confuse anybody? Okay. As I multiply through here, remember this is really over 1. Okay. So sine times sine would be sine squared x over cosine x plus sine x cosine x over sine x. Y'all okay there? That would just be cosine. That's exactly right. But now I have this fraction. How do I add fractions like this? Make them have a common denominator. That's exactly right. So since the bottom here is 1, what can I force that denominator to be very easily? Cosine, right? So I'm going to multiply the top and the bottom. So I end up with sine squared x over cosine x plus that becomes cosine squared x. And now that they have the same denominator, what happens? I can combine them over that same one, right? So sine squared plus cosine squared. And this I hope you recognize right off the bat. If you don't recognize any other identity, always, always, always recognize that one. It is the most common for sure. So I get 1 over cosine, which is what? What's 1 over cosine? Secant. Does that make sense? To my here? I just multiplied, I made these denominators be the same, so I multiplied the top and the bottom by cosine here. Which one? 31? You got it? Say it again. No, because it's not 2x, it's sine squared plus cosine squared. Wouldn't get one. You'd have to put a value in for x. But this is just one of those identities that it does simplify down to 1. 31. The tangent of x over cosecant squared x plus the tangent of x over secant squared. When I get in these kind of situations, again, I try to rewrite anything I can. And so that's always a springboard for me if I don't know what to do. And we do want to combine fractions where we can. So looking at this, I'm thinking let's rewrite these using only sines and cosines and see if it helps us. Does that make sense? How can I rewrite tangent using only sines and cosines? Sine over cosine. That's tangent. Everybody agree? How about cosecant? 1 over sine. Does that confuse anyone? Everybody good there? I'm going to do the same thing on the second fraction. So sine over cosine. It looks messy right now, but just stay with me. And secant is the same thing as now let's do top of the fraction times the flip of the bottom. So let's do sine x over cosine x times sine squared over 1. Y'all okay there? Same thing with the second one. Sine x over cosine x times cosine squared over 1. Good? All right, up top, I have sine to the third over cosine. Everybody agree? Plus, and I'm not going to cancel it out just yet because what I notice is that my denominators are the same now. And when the denominators are the same, I can combine the numerators, right? Say yes, because that's right. Thank you. This looks a whole lot like another problem that we did earlier. What do you notice about the top? I can factor a sign out. That's exactly right. I can factor one of the signs out, and it leaves me with sine squared plus, oh, look there. What do you notice? This just goes to 1. So I end up with sine x over cosine x, which is what? Tangent x. All that, and it comes down just to tangent. Isn't that cool, though? Thank you. I think so, too. I know. Isn't it crazy? Sine squared plus cosine squared is 1. Thank you for your enthusiasm, Ethan. I appreciate it. Yeah, that's cool stuff. Look. Yes. 45. Ooh. Did I give y'all through that? Where you had to write it in factored form? That was the one that I meant for y'all to skip if I told y'all to skip any. The last section, that's the section I was talking about. We hadn't quite got there yet. What else? Tell me about trig functions and how you feel. Are you still so lost, or do you feel a little bit better, or... Everybody give me a thumb. This, I got it, I'm okay, and I don't got it at all. Okay. You can do what I just did on your own if I give it to you.
That one? Yeah, I could do that problem.
Y'all had the odds yesterday. What did you have?
Yeah, we had the evens first and the odds, but evens on the
Okay, everybody do this one real quick. Use identities and simplify. No, not that one. This is one I want to see if you really do, if y'all can really do the ones like what I just did. This is actually number 32.